Okay, hey guys. So today we're going to be going over the problem number 10 on the spring 2017 midterm one. Okay, so this problem is called grid, and basically it gives us this public class array grid, which implements the grid interface. Okay, and so it has three instance variables, a two-dimensional array of integers called nums, and then two variables represent the number of rows in the 2D array and the number of columns in the 2D array. Okay, the constructor is pretty straightforward. It just basically takes in a row and a column and assigns those instance variables as follows. And then additionally does one kind of special thing. What it does is it also sort of resizes, or not resizes, but I guess it expands the array before we even do anything with it. And the reason we do that, as it says here, nums is created with extra space to avoid immediate resizing. So basically it's giving us a little bit of extra space in case we want to add any rows right away. We don't have to resize automatically, right? It sort of gives us a little bit of leeway. That's all backend stuff. You don't really need to worry about all the behind the scenes there. Okay. We also have a method called resize. The implementation isn't shown, but basically what it's going to do is it's going to resize the underlying nums array to be R arrays of length C each. So basically it's going to add column space to each row, if that makes sense. So like if our original, well, actually not just column space, I take that back. It'll add really any space, right? So if it basically just recreates our two-dimensional array to be these new dimensions, R and C, right? So if we originally have a 4x4 array and we want like a 6x8, we would just call resize, resize, and the two parameters would be 6, 8, right? And that would give us a new array with the same elements in it. Keep in mind, it's not a new array that's empty. It's a new array with the same elements that are already in the old 2D array, but it has this additional padding around it from resizing. Okay, and then finally, there's another useful method which returns an int array. It is called get call copy, and basically just it copies the column at index C. So if you want a copy of the third column, we would just say get call copy of 3, and it would give us a copy of the third column in our 2D array. And then finally print. Okay. So the first task that we have to do is write the add row method. And basically what add row is going to do is it's going to do exactly what it sounds like. It's going to add a row to the bottom of our grid. Okay. So before we get into how to write it, let's look at a little example of what add row might look like, right? So here we have a new grid. It's a 3x3 grid. And in this case, whenever we make a new grid, we initialize to all zeros. So the new grid is sort of this part right here. And then they call add call, which isn't a method that we have to implement for this problem, but you can imagine it does the same thing as add row, but just on the column side. So we add a new column, 1, 2, 3, and then we add a new row, 4, 5, 6, 7, and then print. And what that's going to do is it first added this new column right here, and then it added this new row underneath those, right? So now we've been left with basically this was step 2, and this was step 3. And we've been left with this new grid. Okay. So this is probably the more straightforward method of the two. So let's go implement this. So at first glance, it seems kind of trivial to implement this, right? Basically, all we need to do is just copy over the elements from the row that we've been given into our 2D array. So let's just write that. And you might remember this from lecture. You can do this with a pretty simple statement called system.arrayCopy. And what arrayCopy does is it does exactly what it sounds like. It quite literally copies over something from a source array to a destination array. So for us, what that's going to be is I'm going to leave some space because we'll need some room for something else. But down here, we'll write system. Zoom in a bit. System, you see that? Yeah. System dot array copy. And so the parameters for array copy are as follows. So the first one is the source array. So in this case, the source of our data, the things that we're copying over, is the row array, right? The parameter right here. And then it's the start index for the source. So where we're starting in the source array. And in this case, we're just going to start from the first element, right? We're starting from index 0. The next argument is going to be the destination. So now where are we trying to put the data? In this case, we want to put it in nums of, let me see, nums of the rows, right? So the reason we use rows is because we're adding this row to the end of our 2D array, right? And so if we want to add it to the end of it, we're going to need to put it in the last row, which is given to us conveniently by the rows argument. And you might already see where this might go wrong, and we'll get to that in a second. But that's fine. It's adding it to the end of our 2D array. Once again, the destination index is also 0, right? Because we're starting from the beginning of this new row that we're creating. And then finally, we need to specify how many elements we're adding. So like the last argument of system.array copy is how many elements are we copying over, right? And in this case, we're copying over the same number of elements as there are columns in the 2D array, right? So it would be calls. Just let me reiterate that. The reason it's calls is because we have, let's say, 5 columns, right, of data. And so that's exactly how many elements we're copying over, right, from this new array into our new 2D array row. So we're copying over calls number of elements. Okay. And then, yeah, so that sort of does the copying. But what you might have realized before we did this is that we use rows here, but rows would be out of bounds, right? Because like, let's say that we have a 3x3 grid, right? Rows is equal to 3. But if you think about a 3x3 grid, the way that indexing works in Java and most other languages is that this is row 0, this is row 1, this is row 2. So if we try to access nums of rows, right, like right here, we run into issues because this would actually be out of bounds and give us an out of bounds exception. And so to account for that, we need to actually resize before we even think about doing any copying, right? Because we need to sort of make room for our thing before we actually have space to add a new row, right? And so the way we do that is we first want to check if it's going to be out of bounds, right? So obviously when we made a constructor, we already kind of went over this, we were given some extra rows to play with. So technically for that, rows wouldn't be out of bounds, right? But if in fact we are at the very last row of our 2D array and we need to add a completely new row, we need to resize to account for that. So first we check if rows is greater than or equal to, neaten this up a little bit, greater than or equal to nums.length, which gives us the number of rows in the 2D grid. If you are having trouble conceptualizing that, I would encourage you to draw it out just to make sure that you have that down. So if the rows is greater than nums or greater than or equal to the length of nums, then we want to resize, right? So we call resize, which is that method that was given to us up above. And basically in most cases, when we are resizing, you'll want to double the whatever you're resizing, right? So if the original size is nums.length, we just say nums.length times 2. And then since this is only for rows, we can keep the columns the same length. So here we can just pass in for the column resizing, we can keep that the same length, and we can just pass in the same column length, which is nums at index 0.length. And yeah, then let me move this up here. 1 second. Let's move this up. And yeah, and then finally, since we did add a new row, we need to tell our program, our instance variables, that we added a new row. So that last step would be rows plus plus, indicating that we did in fact add a new row, right? Okay, perfect. So yeah, that's the full method for this one. Basically, the important thing is this resizing part that happens up here. This is sort of straightforward once you get the resizing down, but it's important to remember that sometimes we would be at the very end of our grid, like we've already filled in all of the n rows, and we need like an n+1 row. And so to do that, we first need to make space for that. And yeah, okay. So let's go to the second method here, which is rotate column, right? So before we sort of get into how to implement this, let's see what it does. So after we have this grid right here, right, we then need to, we then are calling rotate column twice, right? So first we call rotate column on 2, 1. And so if you look at the parameters, what the comments say is that it rotates column C, only column C, by X positions downwards. So basically what's happening is if we have a column, we have a column 1, 2, 3, 4, and we're given an X value of 2. Actually, let's just do 1 to make it easier. x value of 1, what's going to happen is we shift each element downwards by 1, right? So 1 goes down to here, 2 goes down to here, 3 goes down to here, and then 4, since it can't go down any further, right? There's no space down there. 4 is going to wrap back up to the top, right? So the new column, draw it over here, will look like 4, 1, 2, 3, right? Because everything sort of shifted down by 1, and 4 is gone all the way up. And so one thing to note is that whenever something is being rotated or shifted in this way, and you see something sort of moving back up to the top or wrapping back up to the top, that should generally clue you into the fact that you're probably going to need to use a mod operator at some point, right? Because mod, let's say you have a mod b equals like 1. Actually, we'll leave the equals out for now. A mod b, if a is greater than b, then this mod operator will sort of eliminate all of the greater than-ness, right? What I mean by that is that, like, let's say we have 5 mod 4, right? 5 is greater than 4, and so it doesn't divide really evenly, right? But what's going to happen, this is going to return 1, because this 5 will sort of, we're going to eliminate 4 ticks from the 5, and then we're going to wrap back around to the start of counting again, right? So we go like 1, 2, 3, 4. Instead of counting all the way to 5, we count back at 1, right? And so this is a good way, a good reminder that whenever we do see this wrapping motion, you're probably going to want to use a mod at some point on the indices. Okay, so with that being said, let's get into the actual implementation. So if you think about it, let's say that, or wait, actually my bad, we didn't even look at this example. So let's say we have the example, rotate column 2, comma 1. So we're rotating column 2, right, which is this column. It's at the second index. And then we're rotating it by 1 element, right? So we get this new column, which basically just takes a 6 and moves it all the way up here, and moves the 3 zeros down. Each one moves down by 1. And then similarly, we rotate column 3 by 3 elements. What that's going to do is it's going to take this column and move each one down by 3. So if you have 1, 2, 3, 7, this one's going to go all the way down to here, and then everything else is going to wrap back. So 2 tries to go all the way down, but it'd be out of bounds, so it wraps back up by 1, right? 3 again tries to go all the way down, but it'd be out of bounds, so it wraps back up. It wraps back up by 2. So basically, it starts. It tries to go here, and then it goes here, right? So it's like let me redraw this. The first step is here, the second step is here, and the third step is here, right? That's the third rotation. And then finally, the 7 does the same, and it goes all the way to the third index. The second index, sorry. So the new rotated column will look something like this, right? Everything is sort of shifted down by 3. Okay. So now we can actually get to the implementation. Let me get my notes up. Okay. So the first thing I want to do is we're first going to need to get the column data, right? Because since we're like overriding values and we're like moving things around, if we start moving things around before we get like a copy of some sort, then we're going to lose data, right? Like if I immediately just said, okay, I'm rotating this column by 1, right? So my first step is going to be to move the 6 all the way to the top. Well, if I did that, then I would lose whatever's right here, right? Like I'd lose that data, I'd overwrite it. So we're going to want to make a copy first. And luckily, we have a method that's exactly for that, called getCallCopy, right? So immediately when you saw that method, you should think, okay, this is unique. Maybe I'm going to need to use it at some point in this class. And this is where you want to use it. So we'll make a copy of the column to sort of preserve our data, right? Equals getCallCopy. And then what are the parameters for this? It just wants the column C. So in this case, we're trying to rotate this C column. So we'll just get a copy of that. Okay. And then next, we just need to actually do the copying, right? And so we'll get to the mod thing I said in a second. But if you think about it, for most cases, rotating is actually pretty simple, right? So getCallCopy. Let's take this example right here. This 2. Actually, let's not do that one. Let's take the example of a new column, right? That's 1, 2, 3, 4. And so this is the copy equals an array of 1, 2, 3, 4, right? And basically, let's say that our shift is 1. So let's say x equals 1. So the new array the sort of what's going to be in our new array, for most elements, it's just going to be shifted by 1, right? So for everything except for this last element, all we're doing is shifting things down by 1. So we can implement that actually pretty easily, right? Let's go ahead and write out that for loop, and I'll just leave a little bit of room to make things clearer. So for int I equals 0, I is less than the number of rows, and then I plus plus. So this for loop is basically going to iterate through each of the rows, right? Which means that we're iterating sort of through each element in the column, right? And then so for each of these, what we want to do is we want to set nums of I plus X. So what does this mean? So nums is obviously our 2D array, right? We have this 2D array here. And I plus X, I is the index that we're iterating on, right? So let's say that we're on the 0th row. That means that we're going to be on this row right here, right? And let's say that we're like iterating, maybe we're rotating this column, okay? So we're at this element right here. Plus X is sort of basically what's doing the shifting, right? So now let's say that we want to shift maybe by 2 in this example, right? Let's say X equals 2. So I plus X is going to take us, let me redraw this. I plus X will take us from here down to here, right? Let's just say that this is 2 elements. So instead of being here, what happened? There we go. Stop it. Sorry, notability was being weird. Instead of being here, we're now down here, right? So we've shifted down we've shifted down X number of rows, right? And then the column is going to stay the same as before. So it's just C equals copy of I, right? So what that does is basically it takes the ith element, the element at the ith index, and puts it at the I plus X index of nums, right? Which is kind of exactly what we want to do for everything except for the edge cases, right? So we never accounted for this 4 down here. And that's where the mod comes in, right? So this will work for everything, except for the fact that when we do get to those ending indexes that sort of exceed the bounds of our 2D array, we're going to run into index out of bounds errors, which we don't want to deal with, right? So what we do to counteract that is bring in the mod operator. So instead of this, we say I plus X mod the number of rows. Excuse me. So what this is going to do, let me finish writing out, then I'll explain it. What this is going to do is it's going to take that I plus X number, and it'll work for most cases, right? So let's say that I plus X, let's say that I was 0, right? The I index is, let's say we're rotating index 0, and the shift is 1, right? So then I plus X evaluates to 1, right? What that does is, well, I mean, in this situation, when we're modding it by rows, one mod, let's say our graph has, or our grid has 3 rows, this is still just 1, right? It remains unchanged. But then let's say that we're shifting the 3rd element, right? That means that now we'd have 3 plus 1 equals 4. 4 mod 3 brings it back to 1, right? So it sort of wraps back around, which helps us because now we can sort of avoid this index out of bounds issue that we've been running into, right? And once again, if that's not fully clear, I would write down some examples and make sure that you understand fully why the mod operator is useful here. But yeah, that's about the solution. This method returns nothing, so we don't need to return anything here. But basically what this is going to do is it's going to shift each element until it gets to an element that would technically be shifted out of bounds, in which case it'll mod it, wrap it back around, and sort of begin from the beginning of the array all over again. And yeah, I think that's about it. So I hope that was a useful walkthrough, and I'll see you guys next time.